everyone. Today our chapter is Chemical Bonding Part 2, which is a continuation of Part 1. In this, we are going to know about conditions for the formation of ionic bond, what is covalent bond, types of covalent bond, that is polar and non-polar covalent compound. Okay. Next, conditions for the formation of covalent bond and formation of covalent bond in hydrogen molecule, that is H2, and chlorine molecule, that is Cl2, and nitrogen molecule, that is N2. Okay, first we will go to conditions for the formation of ionic bond. See, in the last part we have learnt what is ionic bond and how it is formed. Now, what are the conditions for the formation of ionic bond? We'll know here. Okay, the three main conditions are low ionization potential, high electroaffinity, and large electronegativity difference. These three are the conditions which are required to form an ionic bond. First, we'll go to low ionization potential. Here, if the ionization potential of a particular atom is low, it will lose electrons easily. Yeah, so the cation is formed easily. See, in an ionic bond, one should lose electrons, right? So, to lose the electrons, there should be low ionization potential, so that the electrons losing will be very easy. Then electron affinity. If the electron affinity value is high, the anion will be formed easily. That is, higher electron affinity value favors ionic bonding. So high electron affinity value is high, anion will be formed easily. Okay. Then if you come to large electronegativity difference, if the difference in the electronegativities of two elements is higher, then the transfer of electrons will be easier. See, in ionic bond, what is there? One transfers the electrons to one more. So this transfer of electrons will be very easy if electronegativity difference is higher. Okay, therefore, more the difference in the electronegativity, more will be the ionic nature of the resulting compound. These three are the main conditions for the formation of ionic bond. Okay, next comes covalent bond. What is covalent bond? The chemical bond that is formed between two combining atoms. There is a mutual sharing of one or more pairs of electrons. See, in ionic bond, what happens? There is a transfer of electrons. But in this covalent bond, there is a sharing of electron. In this picture also you can see, yeah, there is a sharing of electrons between the two elements. This is known as covalent bond. Okay, this and the compound formed due to this bond. Now covalent bond is formed. By this bond, a compound is formed. That compound is known as covalent compound. Okay, this is about covalent bond and covalent compound. Now, in covalent bond, there are three types. That is single covalent bond, double covalent bond, and triple covalent bond. These three types, we'll go through that. See, a single covalent bond is formed by the sharing of one pair of electrons. Here, there is a sharing of one pair of electrons between the two elements. See, that is represented by a single line like this. And in double covalent bond, it is represented by two double lines. Okay, a double bond is actually combination of two single bonds. So, it is represented by two short lines. Okay, a triple bond is a combination of three single bonds. So, it is represented by three short lines between the two atoms. Now, some molecules have the combination of double or triple bond. For example, if you take C2H4, is a combination of one double bond and four single bonds. You can see here, there is one double bond and four single bonds. Okay, in one compound, you can see many bonds. Okay, next, covalency. What is covalency? The covalency of an atom is the number of its electrons taking part in the formation of shared pairs. Now the sharing is occurring. In the sharing, how many electrons are taking part? That electrons taking part is known as, the number of electrons taking part is known as covalency. Okay, number of electrons taking part in the formation of shared pairs is known as covalency. Understood? Now we'll go to types of covalent bond. There are two main things in covalent bond, that is non-polar covalent bond and polar covalent bond. In non-polar covalent bond, the shared pair of electrons are equally distributed. There is an equal sharing of electrons. See, if you take H2, Cl2, O2, they are having equal sharing of electrons. If you come to polar covalent compounds, there is no unequally distributed electrons. There is no equally sharing of electrons here. For example, H2O, NH3, HCl, there is no equal sharing. If you come to non-polar compounds, no charge separation takes place. There is no charge separation here. The covalent molecules is symmetrical and electrically neutral. They are neutral. Non-polar covalent compounds are electrically neutral. If you come to polar covalent compounds, charge separation is taking place. The atom which attracts electron more strongly develops a slightly negative charge. This possesses a slightly negative charge. Okay, example H2O, NH3 for polar covalent compounds. Non-polar covalent compounds, example H2Cl2, O2, N2, etc. Okay, here you can see some pictures about non-polar covalent bonding. See here, even hydrogen is giving one electron sharing and one more hydrogen atom is giving one. So there is an equal sharing of both. So this is non-polar covalent compound. Even in oxygen, there is a equal sharing of electrons. So this is a non-polar covalent bonding. Okay. Now, here you can see non-polar covalent bond. Okay. And polar is what? There is unequal. So the shape is also you can see. Here there is a less electron sharing. Here is a more electron sharing. Here equal number of electron sharing. So this is non-polar covalent bond. Here polar covalent bond. This is polar covalent bond. There is unequal sharing of the electrons. See, hydrogen shares only one. Even one more hydrogen shares one. But oxygen shares more than one. Okay. This is how. See, oxygen has 6 electrons in the outermost orbit, and one hydrogen gives one electron sharing, one more hydrogen shares one more electron. So 3 together shares a stable electronic configuration. See, first oxygen has 6 valence electron, one hydrogen gives one sharing, one more hydrogen gives one more sharing of electrons. So now there is 8, that is stable octet electronic configuration, and so they are attaining stability. This is how the polar covalent bond be. There is unequal sharing of electrons. Okay. Next, what are the conditions for the formation of covalent bond? We'll see here. Both atoms should have 4 or more electrons in the outermost shell. The outermost shell, they should have more than 4 or more electrons in their outermost orbit. Okay. Both the atoms should have high electronegativity. They should have high electronegativity and they should have high electron affinity, and they should have ionization energy. That is high ionization energy. The electron negativity difference between the combining two should either be 0 or negligible. The electronegativity difference should be either 0 or negligible. These are the examples of covalent bond here, water and ammonia. Okay, this is about conditions for the formation of a covalent bond. Next, we will study about some covalent molecules and their structures. Okay, first one is hydrogen. This is a covalent molecule. We will see how the thing has happened. A hydrogen atom has seen one electron in its only shell. It has only one electron. So to attain the stability, they have to attain duplet electronic configuration. Yes. So it needs one more electron to attain duplet. To meet this need, hydrogen atom shares its electron with another hydrogen atom. See, this has one electron and one more hydrogen has one more electron. So if they share electrons, both attains the duplet, that is stability. Yes, so thus one electron each is contributed by 2 atoms of the hydrogen, and the resulting pair of electrons is mutually shared. There is a mutual sharing of electrons, and so hydrogen molecule is formed. You can see here, hydrogen has one electron and one more hydrogen has one more electron. So 2 electrons is there, and so they have formed hydrogen molecule which is a stable. See the electron dot structure, if you can see here, this hydrogen is one electron, one more hydrogen, one more electron. So together they have formed hydrogen molecule. Okay. Now chlorine molecule. See, when two chloride atoms come closer, each contributes one electron and form one shared pair of electrons between them. Both the atoms of chlorine thus attain an octet. A single covalent bond is formed between them. See, if you see, chlorine has 7 valence electrons. Okay. So there is a sharing of one electron from one chlorine atom and one more electron from other chlorine atom, and so they attain octet electronic configuration, and thus they attain stability, that is octet electronic configuration. By this sharing they are attaining stability, and so chlorine molecule is formed. Here if you see the electron dot structure, see there is a sharing of chlorine. This is how the chlorine molecule is formed. Okay. Next, nitrogen molecule. When two nitrogen atoms come closer, each nitrogen atom shares 3 electrons. Why? Because in the valence shell they have 5 electrons. To attain stability they need 8 electrons. They are having only 5. So they are in need of 3 more electrons. So there is a sharing of 3 electrons between the two nitrogen atoms, so that the nitrogen molecule is formed and the octet resulting the stability, and thus the triple covalent bond is formed between them. Here if you can see in the picture, this nitrogen atom has 5 valence electrons. Here also it has 5 valence electrons. So there is a sharing of 3 electrons between them, and thus nitrogen molecule is formed, and this is the electron dot structure. See, there is a sharing of electrons between two nitrogen atom, and thus the nitrogen molecule is formed. Also, this is about nitrogen molecule, chlorine and hydrogen molecule. So remaining molecules will be remaining covalent structures will be studying in the next part. Okay. Thank you.